definitely worse this year than usual.
Yeah.
Okay, so this is one of our inverse questions, like chapter 6. The answer to an inverse is an angle, and what I'm asking you to do is find cosine of that angle. You cannot just like plug these in your calculator, because I'll likely give you something involving radicals or something that's not pretty, just to prevent you from doing that. So I expect work on this. What we know is if it's sine inverse, which quadrants can it be in? That's when sine is negative. Sine inverse could be quadrants 1 or 4. Remember we do consecutive quadrants? It's either 1 and 2 or 1 and 4. You have a positive and a negative, so it's sine inverse itself could only be in 1 or 4. But since this is positive, we are in quadrant 1. What this means is sine of our angle is 21 over 35. So sine is opposite over hypotenuse. Oops, 35. So we could do Pythagorean theorem to get our third side. 21 squared plus b squared equals 35 squared. So if I solve this, and you do your square root, and get a positive 28. So then you are just asked to find cosine of theta. So from here, cosine is adjacent over hypotenuse. So that's 28 over 35. Okay. Question 30. Okay, if I want to solve this on the interval 0 to 2 pi, so that tells me we are in radians. We have to get cosine by itself, but I can't just do that because I have cosine squared, a cosine, and a 1. What can you do with this? So cosine squared breaks into cosine x and cosine x. What multiplies to 1 and adds to 2? So if we set each of those equal to 0, we get cosine equals negative 1. So if you think about your unit circle, cosine is x. X is negative 1 right here, and that is at 180. Since we're in radians, we'll go with pi. This is the exact same, so it's the same answer. So pi is our only solution.
Like even though it's in 4 too, since it's 2.
Say that again.
Like we wouldn't include 2 pi.
Oh, no, because at 2 pi, it would be back to positive 1 instead of negative 1. And we don't have to do the 2 pi k because I gave you just that interval. So 31 is another inverse problem. Remember with our inverse, we had some functions that could be in quadrants 1 or 4. That was the sine, we already saw, its reciprocal, cosecant, and tangent inverse. The others, if you have an inverse, it could be in quadrant 1 and 2. So that's our cosine, secant, and cotangent. I should say inverse on all of these, so you know what I'm talking about. So this is cosine inverse. That tells me my answer could be in quadrant 1 or it could be in quadrant 2. Because I have a negative 1/2, which quadrant is it? 2. Okay, then if I want to set that up, you just have to find your angle in quadrant 2 where cosine is 1/2. So when is cosine 1/2? 60 degrees. So 60 degrees in quadrant 2, so 180 minus 60 is 120 degrees. I didn't specify if you had done radians. 60 degrees is pi over 3, so that would have been 2 pi over 3. So either answer would be correct here.
So on those, do you want us to put like the quadrants?
You probably should, just so you can make sure you answer it in the correct one. 32. I want sine of 2 theta if sine of theta is negative 4/7 and cosine theta is greater than 0. So sine 2 theta, when I see that 2 theta, that tells me I need to go to my formula sheet. If you look at your flip chart, what's the formula for sine 2 theta? Okay. So I have 2. Sine of theta, I already told you, was negative 4/7. I need cosine of theta. So to get my cosine, I'm going to need to set up a triangle. My sine is negative. We think all students take calculus. The negative can happen in quadrant 3 or 4. But cosine is positive. So in which of those quadrants would our cosine be positive? Quadrant 4. Sine is opposite over hypotenuse. Hypotenuse has to be positive, so the negative goes with my opposite side. So then we can find this side. Oops, that's 33. Square root, you have to decide the positive or negative based on your quadrant. So if I went over, that would be a positive. Can we break down the square root of 33? No, so that just stays. So then cosine of theta, adjacent over hypotenuse, is radical 33/7. So if I multiply 2 times negative 4 times radical 33, it's just negative 8 radical 33 over 7 times 7 is 49. Any questions on that? So problem 35. Triangle ABC. Let's draw a triangle. Mine is not necessarily drawn to scale, but that's okay. Angle A measures 137 degrees. Bless you. Angle B is 28 degrees. Side B is 71 centimeters, and I want to find side A. Do we have a right triangle? No. The only time you can use like SOHCAHTOA is if the triangle is right. So instead, what do we have to do here? Law of sums. So law of sines, we had those 3 fractions that were all equal to each other. I will give you those formulas on the final. So I'm looking for a side, so it's easiest to set it up with the side on top. So we would do the A over sine of A equals B over sine of B. So A over the sine of 137 degrees equals side B, which is 71, over the sine of angle B, which is 28 degrees. So multiply over the sine of 137. And make sure you are in degree mode when you go to plug this in. And you get 103.14 centimeters.
When you ground these, do you want them to be to the center decimal or fourth decimal?
Yeah, I guess that was kind of inconsistent. I usually go to 4, don't I?
Well, I know.
0.1412.
I know at like the beginning of the semester you mentioned 4. And
Yeah, that's kind of my standard. If I don't specify in the problem to do significant digits, then 4 is good. Thank you. Is that one alright? Problem 36. We have triangle ABC. Side A is 9.3 centimeters. Side B is 5.7 centimeters, and side C is 8.2 centimeters. We want angle B. So did I tell you that this was a right triangle? No, so I can't do SOHCAHTOA. Instead, if I want to set this up, can I do law of sines?
You have to walk cosine.
Yes. Law of cosines has 3 options. Since I want side B, I need to use the b squared equals a squared plus c squared minus 2ac cosine of angle B. So if I plug that in, we have 5.7 squared equals 9.3 squared plus 8.2 squared, thank you, minus 2 times 9.3 times 8.2 cosine of angle B. You can work this out as you go, or you want to bring everything over. So if I divide, I have 5.7 squared minus 9.3 squared minus 8.2 squared divided by 2 times 9.3 times 8.2. Make sure you've got parentheses around top and bottom if you put it all in at once. And I get my cosine B to be 7.7949. It's positive. Cosine can be positive in quadrants 1 or 4. Are both of those possible?
I'd say no.
No. To be in quadrant 4, your angle has to be between 270 and 360 degrees. Can we have that if you're in a triangle? No. So I only have the one angle, so we just do cosine inverse. And that gives me 37.3542 degrees. A lot of times with these, we rounded to significant digits, so if we did that, it would have been 37 degrees.
I keep forgetting that the law of cosines are a thing. That's the last thing we did.
Yep. Can't forget the most recent stuff.
I mean, my excuse is I've slept since then.
Problem 37. So if I want to change this to decimals, what do we do? Okay, the degree stays the same. Minutes, if I want decimals, how many minutes are in a degree? 60. How many seconds are in a degree? And then we just plug all of that in our calculator. So we get 97.2144 degrees. Problem 38. So I have given you an equation. For the terminal side of an angle. So basically your angle starts at 0, 0, it ends here on that line. We need to find sine, cosine, tangent. So this kind of goes back to way back when we had x, y, and r definitions. So you can remember the x, y, and r. We can also draw a triangle to do this. What you have to do is find a point that would work for this line. So I told you that x has to be less than 0. So you can plug in any negative number you want for your x. I would recommend something that would maybe help us get a non-decimal answer for y. So like if I just put in a 1, my y turns out to be a fraction. But if I put in maybe, we need a negative. So let's try negative 2. Then we get negative 6 equals 2y. If you add that 2y over, divide, so your y is negative 3. So
wouldn't that be positive 6 since you have to add over the negative 6?
I added over my negative 2y.
Oh, okay.
So you have x and y now. You need r, or if you prefer to think in terms of triangles, this is the point. So this, I'm looking at this triangle. This side is negative 3. This side is negative 2. We need the hypotenuse. So negative 2 squared plus negative 3 squared equals r squared. So that missing side is the square root of 13. Then I'm asking for sine, cosine, and tangent.
Where did the negative 2?
I made it up.
Okay.
You can pick any number you want as long as it meets this requirement. So since I said less than 0, I did a negative.
Okay, so like in the equation, like the negative 2 squared, you plug that in for.
Oh, right here?
Yeah.
Yes. So I was using it like from my triangle, or you could think the x squared plus y squared equals r squared. Okay. So you can do these based on x, y, and r. If you didn't draw a triangle, we know sine is y over r, cosine is x over r, tangent y over x. Or if you set up your triangle, you can think SOHCAHTOA. Sine, opposite over hypotenuse, so that's -3 over the square root of 13, but we know we can't leave a radical on the bottom, so that's -3 radical 13 over 13. Cosine x over r, or adjacent over hypotenuse, so -2 over radical 13, or -2 radical 13 over 13. Tangent y over x, or opposite over adjacent, so -3 divided by -2, which is just a +3 over 2.
So we can pick any number, what if we don't pick the same number like you?
It will reduce to the same thing.
Okay.
So, yep, any number as long as this problem said x had to be negative. So any negative number will work there. What else, guys? Anything else on this study guide that we have not talked about and you would like to?
Can we do 34?
Yes. Okay, so I told you in the picture, side BC is the square root of 21, side BD is 5, and AD is 6. We need to find AB. Now remember, to use a right triangle, or to use our trig functions, we have to have a right triangle. So if I look, this BDC, that little triangle, is a right triangle. So we could find this side down here. So I could say like y squared plus radical 21 squared equals 5 squared. So y squared equals 4. Square root, since it's a triangle, we don't need plus and minus, so we just get that side to be a 2. I can't just look at this little piece unless I want to start breaking out law of cosines or something like that. But if I look at the big triangle, this whole thing is a right triangle. I don't know this side. This is radical 21. I just found that from here to here is 2. So what's this entire side? So then we could do Pythagorean theorem again. So 8 squared plus radical 21 squared equals x squared. So 85 is our x squared. Square root, break down the radical if you can, but 85 is not divisible by any prime numbers. So that's the final answer. What else? We still have time, so anything from the whole study guide, or anything that maybe you don't need me to work that problem, but you would like for me to work another one like it on the study
I'm
guide?
still a little bit confused by.
So it says find the radian measure, which to use any of our formulas, we have to put radians in and we get radians out. We can't put in degrees, we don't get out degrees. Of a central angle, so we are trying to find the angle. What variable is an angle? What? Theta. Cutting off an arc length of 6 inches. What variable is arc length?
That's W.
The omega is the angular velocity. In a circle with a radius of 2 inches. So radius is r. So if we look at our formulas, this is just S equals r theta. So S is 6, r is 2, we don't know theta. So our theta is 3. so if I asked you to prove this, which side would you box in? The right. Okay, so we have to work with the left. What would you recommend doing first? Distributing what?
Doing the our
Yeah. We need to take care of this square first. That square is saying you have two of these parentheses. So we have to FOIL. So if you do that, you get cosine squared x minus sine x cosine x, and minus sine x cosine x is minus 2 sine x cosine x plus sine squared x. Look at that parenthesis for a minute. Is there anything you recognize in there?
Make it 1.
Yeah. Cosine squared plus sine squared turns into a 1. So then if I distribute my negative, my 1's cancel, and I have 2 sine x cosine x, which is the same as 2 cosine x sine x. I just wrote them in a different order. Okay. What else? Do you want another? And my directions are just to simplify this as much as possible. If you want to add these fractions, what do we need to do? Common denominator. Okay. So what do I have to take the first fraction times?
1 minus sine x.
I'm going to do that on top and bottom. And the second fraction needs? So if we do that, we get 1 minus sine x over, if I go ahead and multiply the bottom, I get 1 minus sine x, and plus sine x cancel, minus sine squared x, minus on this one we get 1 plus sine x over 1 minus sine squared x. What should I do with my minus? And then since these denominators are the same, we can make one big fraction. Positive 1 and negative 1 will cancel. Negative sine x and negative sine x is negative 2 sine x. What do we do from here?
Change 1 minus sine squared x into cosine.
How did you get the sine squared?
When I did sine x times sine x when I FOILed. Okay. So then we're really just almost at our answer. You have to remember what cosine squared means is cosine times cosine. So we have a negative 2. What is sine over cosine?
Tangent.
And then I have, this is just like a 1 over cosine, which is? How do we do the first one?
You find tangent first.
This is just an angle, and we have to find to be in quadrant 1 or 4, but 3/7 is positive, so it's quadrant 1. Tangent's opposite over adjacent. So find our missing side. So we get c squared equals 58. Square root, is there any perfect square that goes into that? No, so we just keep it. So sine, opposite over hypotenuse, 3 over radical 58. So that is 3 radical 58 over 58. Next one, cosine 2 theta. There are 3 formulas for cosine 2 theta if you look at your flip chart. You could use any of them. Which one might be the easiest on this? Grab your flip chart. Your options are 2 theta, so double angle, cosine squared minus sine squared, but we don't have sine. 1 minus 2 sine squared, we don't have sine. We can get it, that's not a big deal. But the other one is 2 cosine squared minus 1. If I use that, I don't even have to find my sine. So I can just plug in my cosine theta is negative 5 over 17 squared minus 1. So you get 50 over 289 minus 1, and you can certainly use the calculator on these. And you get negative 239 over 289. So don't make more work than you have to. If you have options on your formula, pick the formula that's the easiest for you. Is that alright? Anything else you guys want me to go over? What if I did another, if I said the terminal side of theta is given by the equation 3x minus 2y equals 0, where y is greater than or equal to 0. Find cosine theta and tangent theta. Okay. What do I need to do first? Okay, make up a y. We said y has to be greater than 0, so give me a positive number for y.
I chose 2.
Okay, so if I put in a 2, you get 3x minus 2 times 2 equals 0. Get x to be 4/3, which is certainly fine. Do you like dealing with the fraction?
Not really.
Could you avoid it?
Maybe.
We could pick a different y. If you get something and you don't like it, pick a different y. Ultimately, we're going to have to divide this thing by 3, right? So just plug in something divisible by 3. So 3 would work. So you get 3x minus 6. So if you add your 6 over, divide by 3, you get 2. So we got nicer numbers. If I wanted to use a triangle, I can. My x is 2, y is 3, so it's in the first quadrant here. So you can find your r. We know x squared plus y squared equals r squared. r to be radical 13.
I feel like it's always radical 13.
Only because I had 2's and 3's, and I think I just made this one up, but I'm pretty sure the one I gave you on your study guide had 2's and 3's as well.
Yeah, it's the
I
same thing.
remember when we did this before.
Oh, it was the same thing, just different
Greater and
quantities.
lesser than, there's no differences.
I should have been a little more creative in my problem. Apparently 2 and 3 are my favorite numbers, guys.
I remember when we did this before though, it always seemed like the angle was always radical 13.
That was just, it's not the case, but that's always true. So cosine adjacent over hypotenuse, 2 over radical 13, gives us 2 radical 13 over 13. Tangent opposite over adjacent,